The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
Mitsubishi.
All right, guys, so I think we have a problem. I've had a couple of people come up to me and say that you guys always talk about food at the beginning of your show.
Yeah, we do.
Can't you
No
talk
way.
about something else? And Steve, you yourself said to me that we should probably talk about something else.
Right.
Really? So,
Right, so
do
let's
we
talk
need
about
to
something else.
Cars?
Cars.
All
Oh,
right.
Yeah, that's a good idea.
That's a good one.
Yeah. So, Paul, what's your dream car?
I think a dream car, if money were not an object, I'd love to have a cherry red 1965 Mustang convertible.
Hatchback.
That would
No.
be my nice toy car.
You going to drive that to work every day?
No,
or-
I'm not going to drive it to work. I wish, you know what? This is, we're getting into the late summer, early fall. Great time of year to run around with the top down. It's not too hot. It's
Yeah.
been raining a lot lately, so it wouldn't be used. But I tell you what, I wish I had a 65 Mustang convertible Labor Day weekend. Oh. Right? I would have taken it to this Greek church in Marlborough, Massachusetts, where they had this festival. The food there was amazing.
Oh, my goodness.
There we go.
Great food.
It was great.
I love
so,
Greek food.
I'm gonna butcher the names of the church and all the food, but it was actually Saints Anahiroi Greek Church, and apparently these two saints were doctors back in the day that they would treat people. They were like ancient doctors without borders. They would treat people and not take their silver for it. But my wife and I. And one of my kids went there. So the first thing I got to go there every year. Got to have a gyro. It's Gyro. It's not a gyro.
Sure, it's not a
not a
gyro.
gyro.
It's not a gyro.
Or a
They
gyro.
told me it's a gyro.
Hito.
Right? And you got a piece of pita bread. And they put tzatziki sauce on there, which is like a yogurt with some dill and some other spices in there. And they throw lamb. And
That's good stuff.
oh, it's so good with them. There's
That's
tomatoes.
good.
There's
With
some
spices.
lettuce.
Oh,
my
my
mouth
little
is
four
watering.
Barrel and
just
some
thinking
headers,
about
and you
it.
got a good one there.
Right?
Well, I'm
And
hungry now.
They had something called again, the names are souvlaki, which is it's similar, but it's like a pork. Like they cook it on a grill. Oh, it's so delicious.
That's good stuff.
Now, what? I'm not so really familiar with Greek food that much, other than Greek pizza. But you go into a Greek restaurant or fast food Greek or food truck even, and you got that big chunk of meat on, and it's spinning
lamb.
on this.
I don't know what that's called.
Spit, and that's what isn't
They
that what they
slice
make
it.
a gyro out of?
A hito, yeah, they take that meat and
Hito.
they slice
Shave
it.
it.
Not gyro. Hito.
They slice it right off of there and they put it in here, right? So that's what I go for. My wife, she likes spinach, so there's something called spinacopita, which is like that phyllo dough, which is the same thing they make baklava out of,
That's-
so
that's good
it's
dessert.
rolled very thin. They got dessert.
And I love it with some green olives.
Yeah, dessert.
It's gotta be some car, Paul.
Dolmades is, I think, grape leaves, which is very good. But there's something I'm trying. Oh, yeah, these little. They're like these little. I don't know what you call it, almost like a macaroon. Lucamades, like this little dessert. It's so good. It's like a fried doughy thing.
So much for talking about cars.
Yeah, well, that's
Yeah.
what I would do if I had a 65 cherry red Mustang convertible. Listen, the people spoke. They said, talk about something else. So we talked about cars.
We did.
For like
We're
2
done.
seconds.
Yeah.
Like, okay, no.
Yeah.
The
We did
point
good.
is, I gave them people what they wanted. We talked
Exactly.
about cars.
Yeah,
Okay.
that's what we do.
So let's get down to business. What are we going to talk
Welcome to the METUS Tech Show, everyone. We have Dwain Barcklay back on the show again, and by popular
doing?
demand.
about? Dwain was here for the Heat 2.0 QHV
Yes.
product
Very
several
good
episodes
episode.
ago. He's a wicked smart guy from Northern California.
Smart.
Dwain, would you be considered
smart?
Northern? Smart.
It's very smart.
Wicked smart.
That's
guy.
It's
not
not
California
smart.
though.
Well, it's
That's
just
smart.
Bad.
No, you're from. Yeah. Would you be considered Northern California?
Northern California,
Sacramento
Yes.
area?
That's
Sacramento.
the only place you can get that accent.
Juan Cardona. Everybody
Yay.
knows Juan. And we
Hola,
got
amigos.
Paul Shaves and myself, Steve Pimentel, back on the show. And we're at the 2023 DSG conference. So we got some noise behind us, people walking by. There's a lot of excitement here, a ton of breakout classes.
Yeah, we're in Alpharetta, Georgia.
Yeah, so we're grabbing anyone we can for a podcast, trying to get them on here. And today's topic is city multi-technology. And we really want to get into more city multi episodes and this is a great opportunity having Dwain on. And Dwain, we're going to start by talking about Y series heat pump operation.
Okay.
Right. So Y series heat pump, as we know, it's either heat or cool,
It's
just
a
like
heat pump.
any heat pump.
Exactly. Yep.
Right. So where does all the subcooling happen in a Y series system? At
the outer unit.
Yeah.
Yes,
it
that's
has
where
to
the
happen out there.
subcooler is.
And what's the benefit of the subcooling? What is subcooling? You know, really, that's where you gain capacity and you
Absolutely.
really increase efficiency.
Yeah.
So subcooling is a huge part of these products.
Yeah, definitely. And at Mitsubishi, I always say this: we're very subcool happy at Mitsubishi. We're always subcooling wherever we can through
Well,
receivers. We
You
do
can't
it.
have refrigeration
Right?
without subcooling. So
Subcooling.
you need subcooling.
We can't have refrigeration without liquid at the evaporator.
That's right.
Yeah.
Well, that's subcooling.
Well,
Yeah.
subcooling, where did it start? It started with refrigerant piping that when you had to overcome pressure drop on liquid lines, right? So what did we do to overcome pressure drop is we used subcooling. So the more subcooling you got is how you like vertical risers on reefer systems.
Yes.
You would only go up so high, and then you were having a problem with flashing off of your refrigerant. So we subcooled it.
Yeah.
So you think of that and you put it in the context of, okay, if we're going to use heavy subcooling, we can overcome pressure drops because we're carrying enough capacity in that refrigerant.
Right.
And it's all
we-
about efficiency, right?
Yes,
So-
and we know that subcooling is taking the temperature of that refrigerant below its saturation temperature, so we can have a full line of liquid get into the indoor head.
To the metering devices. And
Yeah,
the metering
exactly.
devices, unlike the residential product, the metering devices in the city multi-site are all at the indoor units.
Yes.
Every indoor unit has one.
Yeah, so we're using headers and tees, right? We're using headers and tees to feed our indoor units. Unlike,
I've got my two pipes coming from the
Yep.
outdoor unit. I go inside the building, and I start going to the indoor units. That's right.
yep,
No branch.
So that
lines. We'll
makes
talk
it
about that
easy
in a minute.
with headers and tees, and especially tees, right? I mean, easily accessed to get about anywhere that sells refrigeration.
Yes.
Copper and components, fittings. So that's nice that we use something that's very standard and very easy to get off the shelf compared to other brands.
Right.
You know, they have some of them use special fittings. You got to put
fittings,
angles, special tilts and angles on things, and that's one thing we have very well going.
So
for
we
us.
can just run one of the lines. You know, let's take the liquid line. We run that through the building. We tee off, go to an indoor unit, make the liquid line connection, continue on, move to the next unit, and so on. And then we do the same thing with the suction line.
Yep.
Yes.
Yeah.
And so, being that it is a heat pump,
Yep.
we can expect for one side of the building to be calling for cooling, and the other side of the building to be calling for heating.
No, yeah, this
It
is
is not a heat
right.
recovery
The
system.
entire system is in the same mode. We can't have mixed mode. So, not an ideal probably for an office building or a hotel where you might have
Or even
mixed
a school.
modes, or a school or a building that would have solar load in the morning on one side and that switches
Absolutely.
to the other side in the evening or afternoon. So
so
we have
very
to change
common
it over.
for southern states, the islands, warm climates to have a Y series system. Not so much a simultaneous heating and cooling system.
Right.
Right. And I just want to back up a second and talk about the subcooling again. So we're subcooling in our condenser coils at the outdoor unit. We're
Partly.
also
Yes, that's where it
subcooling
begins.
in a subcooling coil,
Yes.
a tube within a tube,
Heat
right?
exchanger.
Heat exchanger at the outdoor unit and getting to that final subcooling target.
Yes.
And
Which is-
controlling it.
Yeah.
Right? Because what you're going to get from your outdoor coil is limited. There's temperature differences that are going to play into subcooling through a coil or a heat exchanger. But then you've got the LED controlled tube and tube setup
Yes. Yeah.
where you're going to control precisely how much subcooling do we want this thing to achieve. So we have the ability to control subcooling with those subcooling circuits.
Yeah, and we can measure subcooling before
Yes.
the tube and tube and after the tube and tube. So we
And
can
that's
have
what I
some.
was just going to say.
Yeah.
Not only are we monitoring the subcooling out of the condenser, we're monitoring the subcooling downstream from the subcooler,
Yeah.
which is what we consider total subcooling.
So being a heat pump system, there's going to be times we need to switch that system over, right? Especially on the shoulder months.
Yeah, we call that changeover.
Yeah. So system changeover happens one of two ways. So there's a weighted average. Can you explain a little bit on how that weighted average works?
Yeah, the weighted average, first of all, to set it to really function as a weighted average changeover, you're going to have a central controller because that's a setup function through central control. And what it does is it's looking at weighted average plays exactly what it says. The weighting of the system is based on the fan coil size. So depending if you got a 6,000 BTU fan coil or a 5-ton 54,000 fan coil, those are going to play different weights because a 6,000 BTU fan coil doesn't have that much capacity compared to the 4.5, 6, and 7-ton fan coils. They've got to have more capacity. So weighting is really looking at the size of that fan coil.
So it's almost a voting system, right?
So,
Yes.
yeah,
By size.
I mean, so
Well
would
said.
you say that it's more about capacity than it is demand?
Well, the demand plays into it as well, Juan.
I'm sure it does.
So you've got to look at that. If you have a room that's got the 6-ton fan coil in it and it's 4 degrees away from set point needing cooling, and then you got that room with a little 6,000 BTU unit and it's 4 degrees away from set point, who needs more cooling? Well, unfortunately, the weighted average says they both are going to need cooling.
Right.
But we're going to, if one of them switches their modes over and it goes to heating, well, that little 6,000 BTU in heat compared to the 6-ton unit in heat or cooling, that is the weighting right there that's going to say, well, wait a minute, we're not going to switch all of our capacity over just for this little
heating, just because
6,000
of that
BTU
unit. Yep.
fan coil that's calling for heating right now. We got a 6-ton air handler that needs to take priority, and we need to have that finish its cooling cycle first before we even consider a switch over for that little 6,000 BTU zone to heat.
Yeah.
Ideally, would you use weighted average on a system that had similar sized indoor units throughout, or does that really make a difference?
No, I think that's probably the better application for weighted average, Paul.
Yeah.
I would say, yeah. When you're much more closer in size, I think it's going to be much more effective than when you have lots of different sizes from small units to large.
So
units.
if you got 25 units in this system and they're all 8,000 in the same capacity range, that's the ideal situation for using
that's
the
what I
weighted
believe
average.
would be the best.
All right.
Yeah.
What's another way to change over?
So another way we have is that it doesn't really have to go through a central controller unless you want to establish an address that you want to take over and have a master control through. But we do a changeover process. It's the only time you would consider maybe an automatic changeover, and that would be through a dip switch selection, where if you flip that dip switch, that is going to say, okay, what's the lowest address fan coil you want to take control or be in control of its mode? So that particular fan coil acts like an auto mode on its controller, and that lowest address, so it actually plays a master mode control.
All right.
And that would be a dip switch at the indoor unit?
The outdoor, that's
At
in
the
the outdoor unit.
Okay.
The outdoor
I
unit.
just
Yeah.
want to clarify on
So
that.
whoever's in charge of the building would be address 1 in this, for example. And if they switch their controller to cool and the whole system's in cool, and if they switch their controller to heat, the whole system's in heat.
Yep. No, it's a way. Obviously, you wouldn't want to just pick a little sub-zone to take master control for a whole building. You know, if it was a residence, you kind of get a better understanding in a smaller application where, like, the main quarters of the house, the living room, kitchen, family room area, it kind of could take control so that the bedrooms could follow. So the same thing in a commercial structure. If you're going to use some kind of a low address, it's going to have to be a main area, probably an area that's got more people in it. Maybe a bigger work area, more of a changing load to speak of through those shoulder seasons. Those are the perfect environments where you could use those lower addresses, but you're going to have to strategize which fan coil are you going to pick for that lowest address.
Yeah.
And
when
that
you
makes
set that
sense.
up-
That makes sense on the demand side. The higher demand would overtake the capacity. Because in and you mentioned the shoulder seasons. The shoulder seasons are not going to require much cooling or much heating. So yes, the demand will play into that.
Yes.
All right. Before we go on to the heat recovery system, is there anything else that we need to know about the Y-series system?
Well, as Steve already mentioned, that is an ideal. If you have an application where you're staying in a mode pretty fairly consistent, and Hawaii is a great example, right?
Yes.
I mean, you've got a pretty much a cooling system, but they do put heat pumps in. But how often will those systems really go into heating?
Very
So
little.
that's a perfect application. Or if you had a cold climate situation where you didn't have those real hot days and have a large cooling load. Works out perfect
Yeah.
to have something that really is going to focus itself in the strategy of operation being so much
I normally
easier.
say Orlando on south.
Yeah, funny story too, because I was teaching a class down in Miami for a bunch of our IBU partners from the islands, right? So they were all from the Caribbean, from Bahamas,
Right along the equator,
And I'm going through R2 system operation,
And they have no
and they're
idea.
looking at me like deer in the headlights, and I had to ask, I'm like, is there something you're not understanding? And like, we don't do anything with
Yeah.
R2 systems, and it blew me away. I'm like, I never thought of that.
Yeah.
Everything's
And by the way, the
Y
IBU
series.
stands for International Business Unit.
Yes. Thanks, Juan, for that. So let's move on to R2 series heat pump operation. And this is where things get really interesting, right?
I love it.
So R2 is a heat recovery system.
Yes.
Yes.
Right? And what does that mean, Dwayne? I like when Dwayne
So-
explains it. I understand
Yes.
everything he says.
So the heat recovery
Excuse me.
process, or you'll hear a lot of times simultaneous. And it's interesting because, people will talk about VRF and they'll say, oh, I got a VRF system. And unfortunately, there's a misconception that all VRF units are simultaneous heating and cooling. I don't know how many people I've talked to,
yeah,
and
not
they
so.
have that perception, especially the end users that buy these things. And first of all, that's the one thing that we try to break out of is no, VRF has nothing to do with the simultaneous heating and cooling. It's part of it, but that doesn't mean you get that when you buy a VRF system. But the simultaneous is saying that any type of product, and just use a simple heat pump, single zone, single speed heat pump. You're either going to be in heating or you're going to be in cooling.
Right.
So how do you get simultaneous heating and cooling at the same time? Well, obviously you're not going to be doing it on a single zone. You wouldn't need it. It's going to switch over automatic. So you're going to get a building that have multiple zones, and they having multiple zones, as you pointed out earlier, where's the load at in that building? Commercial buildings, that load varies. That load varies by where the sun is
shining
coming
on it.
in,
Absolutely.
how many people are
Where
in
the
there,
people
what the
are,
machinery is
Yep.
inside of the space.
How
So
many
there's-
windows? Everything.
Windows. So you get
Well,
a lot
that's
of
why-
times where in those shoulder months especially, you're going to have rooms that are going to need heating and you're going to have rooms in zones that need cooling. So that's where your simultaneous is going to shine. And really the concept of the word heat recovery came from really the thought of, well, if I've got too much heat in this room, can I move that heat around and get it where I want that heat?
Right.
Cool that room down, pull the heat out of that room and put it somewhere else. And that's where the concept began, heat recovery. Now we can take that temperature and we can move it around the structure. And that becomes a process that becomes somewhat mysterious to a lot of people in the sense of, okay, well, how do you do that? Well, if you just take basic refrigeration, basically your compressor is putting out hot gas, high pressure hot gas on one side of itself, and then it's going through refrigeration process to pick up or move heat around and bring back superheated vapor back to the compressor.
itself.
So there's a whole process in between that. So the whole thing stems from if we've got hot gas available, this is the unique part of it too with Mitsubishi is it's a two pipe.
Right.
Yeah.
See-
And we hear, I mean, that's when I came onto Mitsubishi, that was the biggest hurdle I had to overcome. I can understand a hot vapor line on heating. But when you talk about a saturated liquid traveling through a liquid line to the device that I know you're going to get into it, I mean, I really had to study this system for me to understand how it did what it does.
And that is there's a lot that goes into it, right? It's very simple from the standpoint of you're moving hot gas or saturated refrigerant. Okay.
Yeah.
So one of the things you've got to strategize is when do I want hot gas and when do I want that to be a saturated liquid? Well, it all depends on how many zones are calling for cooling, how many zones are calling for heating. So if I got a lot of zones that are calling for heating, my line's leaving my outdoor unit in two pipes. One line is always my high pressure line. The other pipe is always going to be my return or low pressure return line. So basically we can strategize if we want hot gas, we just send that high pressure around the outdoor coil. We don't cool it. And we can send it to our branch controller through that high pressure line. If we've got a condition where we do have a little higher cooling demand, we're going to run some of that refrigerant through the outdoor coil, and we're going to bring that refrigerant right down to its saturation point.
And that's the beauty of it, because there's a specific LEV in the outdoor unit that allows that hot gas to mix with that liquid to go into the branch controller, which we're going to talk about here in a minute. And I mean, I could not wrap that up around my mind how this thing did what it did, but I finally went to the branch controller, and then I saw how it did what it does, and it was like a light bulb coming on.
Yeah.
So a Y-series unit, we have an outdoor unit, we have 2 pipes going in, and we tee off, or we go to headers, and we go to individual indoor units.
Yeah.
Right? Now we're talking, and that's the whole system is in heat or the whole system is in cooling. It's all or nothing. Now we've got heat recovery, we've got the R2 system, we've still got the outdoor unit, we've got 2 pipes coming into the building, but they're not going to the indoor units just yet, and you both mention it. We call it the BC controller, branch circuit controller, and that's really the difference. That's the heart of the system and what allows us to do that. So I'm the refrigerant. I'm moving along. I'm coming in on the liquid line to this BC controller, right?
Yep.
And now I have a decision to make, right?
Yep.
So take it from there, Dwayne.
Yeah, you're coming into the intersection, right? As you're driving along, we come into that. Again, are we going to be coming in as a high-pressure hot gas, or are we going to be coming in as a saturated or liquid vapor mixture into that branch controller from the outdoor unit? And that really now becomes where the whole heart of our R2 system takes place, is in that branch circuit controller. The first thing it sees is a gas-liquid separator. So that's a unique feature in itself.
Very much so.
What is a gas-liquid separator? Well, we do a good job describing it. It separates gas and liquid.
Yes, and I mean, we call it magic, but there's no magic.
No.
It's actually managing refrigerant.
Yeah. So it comes in there. It's like an intersection, right? The gas is going to go up, and the liquid's going to go down. Little gravitational change. So if we've got zones that need heat, we can take that high pressure, high gas, the hot gas, or heated gas off the top of the separator. And what the cool part of this branch controller is now it has that ability to separate gas from liquid. We use liquid for cooling, and we use gas for heating.
Yes.
So then it has to be managed on what direction does that refrigerant flow. And typically I like to always use the example of, if you had a one-stage heat pump, you're going to have, and one-speed compressor, it's very simple operation. You're going to take an air conditioner and reverse its cycle, or reverse their flows to get heat, the high-pressure hot gas to go to the indoor coil to heat with, and then the low pressure is going to go to the outdoor coil. So you kind of switch your evaporator and your condenser.
Through the reversing
to that.
valve.
Exactly.
So the cool part about that branch controller and the number of zones is you have solenoids in there. And you could think of this branch controller, if you got 16 separate ports on that branch controller, it would be like having 16 reversing valves for each fan coil that you're going to hook up to it. So we're doing it with solenoids, but the concept being is you took that as a reversing valve and you say, okay, this fan coil needs heat. I'm going to change that position of that reversing valve so that it sends the high pressure hot gas out to that fan coil. And then when you got the cool fan coils that need cooling, that reversing valve switches its position because it's now the reverse flow direction than it was in heating. So now we're going to send out this high pressure subcooled liquid to those fan coils that need cooling. So now you get this exchange of energy, it's this exchange of heating. So it's a real simple concept, just looking at that as a reversing valve. It'd be like having numerous reversing valves inside that box.
That's a great way to put it.
Yeah, it
Yes.
Yeah.
But however, it's solenoids. We're doing it with solenoids.
Yeah. Three solenoids, A, B, and C.
A, B, and
Solenoids
C.
A, B, and C.
AC for cooling.
And I
B
just
for
want to
heating.
point out the gas liquid separator, don't think too deep into it. It's basically a copper tank.
Yeah.
It's a
It's a
receiver.
copper tank. It's nothing fancy inside of it. It's just a pipe, like you said, Dwayne, coming out the top, pipe coming out the side. And, I always get the question from students in class, does the branch controller need to be level? Right? Because, that may affect the way the operation of my refrigerant, right?
When I was teaching classes, I used to hold up a water bottle half full of water. And I said, just imagine, if what's going to come out of the top of the bottle if I increase the pressure on it, the lid was off. I'm going to have vapor come out of the top. And that's basically it. And if there was a hole on the bottom, I'm going to have liquid come out of the bottom. That's basically all it is. There's nothing mechanical about it. It's just a tank.
No, and it's... Go ahead.
And on the Y series, on the heat pump systems, we talked about subcooling happening at the outdoor unit. So I know the branch controller, we have subcooling as well as superheat. Can you talk about that? What's going on at the branch controller?
Well, again, like we talked about with the Y series, it's all about subcooling, right? And where we did it in the Y series was in the outdoor unit. R2s are doing our main subcooling work inside that branch controller. Mm-hmm. So we separated that refrigerant in the gas liquid separator, and we can take that liquid off the bottom.
Yep.
And those zones that need cooling, we're going to need to subcool that refrigerant. Yes. So we're going to actually have tube-and-tube heat exchangers in there controlled by its own LEV that we're going to be able to cool that liquid line down and precisely get the amount of subcooling off of those tube-and-tube heat exchangers that we want. So that way now we're efficient at sending out subcooled liquid refrigerant. Again, the concept being is we can now also have the ability to carry enough capacity in subcooled liquid to do a major functional work. Yes. Inside of each of those fan coils that need that cooling.
Yeah, so let's think of a very basic R2 system. 2 indoor units. One's calling for heat, one's calling for cooling. Indoor unit that's calling for heat, what do we have for refrigerant coming out of that unit? It's subcooled liquid.
Yes.
So all we need to do, we don't need to bring that back out to the outdoor unit for subcool. We just bring it through a tube and tube.
To the unit that's
and
calling for cooling.
Branch control, the main branch control, is the heart of the system, and and so much work can be done, and this is where all of the efficiency comes in.
It's a beautiful thing.
And I mean, we could talk about cooling patterns and heating, and segmenting of the outdoor coils. That's something else we do.
Yes.
We can use as much or as little of the outdoor coil as we need by segmenting it. And that's for a later podcast. We can get into, it just can get really crazy.
Yeah.
One step at a time, Steve.
Yeah. In a ideal system, in a perfect scenario, I got half the building needing cooling and half the building needing heating, and this is the textbook definition of heat. It's just take the heat from where you don't want it to where you do want it.
Yeah,
and that's it. And then my compressor's running, but my outdoor fans are off.
Don't even
need to run.
Yeah, and that's what heat recovery is all about. And really, are you going to see half the building calling for heat and half the building calling for cooling? You can. Yeah, it's very rare. It's like I call it a Sasquatch riding a unicorn, right? And you see that system. You go up to that outdoor unit, and that outdoor unit is barely running, and that's right in that situation. That compressor's ramped down. The condenser fan motors are barely running, if at all.
Yeah,
and you're getting all the savings.
I've actually seen a maintenance tool file with the system was 50-50.
Really?
It was perfect. It was 50% capacity. It was years ago that I saw it. A former employee is no longer with us. He retired. But he showed me this maintenance tool file. It was an R2 system and perfect 50% capacity in heating, 50% capacity in cooling. So it can happen.
Absolutely.
But the point is, it doesn't have to happen. This is still efficiency. No matter what, I'm taking heat from the people who don't want it and giving it to the people who do, or the rooms and so on.
So we have 2 pipes going from, speaking of the heat recovery or the R2 systems, we have 2 pipes going from the outdoor unit to the branch controller. Where do we go from there?
So the 2 pipes from the branch controller, leaving actually again going through that solenoid as they do for each of the fan coils. And let me just back up. I thought of this was a good way to share. Is what does your condenser do versus what does your evaporator do? Right?
Yeah.
You've got that. If you simplify this thing that easy and just say I got a compressor, I got a condenser, and I got an evaporator, and I got a metering device.
Yep.
Well, some of our fan coils that are in heating become our condensers. Yes. Some of those fan coils in cooling are our evaporators. Correct. So there's the latent heat changes of the refrigerant taking place, the heating and cooling. We're reversing the flows using those solenoids, or like the 4-way valve, wet reversing valves. So really, it's a very simple process. Once we steer that refrigerant out of that branch controller with those solenoids, we're now saying, okay, those fan coils need heating. We're going to send them high-pressure hot gas. There you go.
Yep.
And that flow is going to go out as a gas, going to go through that indoor coil. We're still going to have a metering device in there that's going to do a little bit of work. I mean, it's not a true metering device. I call it a flow control.
Yeah, it's more like
We're controlling subcooling when that condenser is in heating. We're going to have subcooling take place inside of that coil, and it's going to return back to the branch controller as a high-pressure subcooled liquid.
Yeah.
So 2 pipes coming in from the R-2 unit to the branch controller, and then there's, depending on the size of the BC controller, there are ports with 2 pipes going to each indoor unit. One sending refrigerant, one bringing it back. And how many of these BC controllers can I put on our largest system?
Yeah, that's some new technology that we upgraded to too. Our older systems were a single main with 2 subs,
Right.
And now you can have a main with up to 11 subs.
So the N generation,
Yes,
Yeah.
with the engine.
So I've got my main BC, and am I still going with 2 pipes to those sub?
No, that's where we do change. So the way they structure inside of the main branch controller is there's 2 subcooling circuits. So when we have subs, they're not as big, and we don't want them as big as we do a main. So most of our working parts are in our main branch controllers. So the liquid separator's there. We've got 2 tubes, heat exchangers do subcooling, so we have 2-part subcooling going on. And then we got our solenoids to switch the number of ports out to the number of fan coils that are in heater cool. Well, sub just says, okay, we don't need all those components in the sub. So we don't need the tube-and-tube heat exchanger in the sub, and we don't need all that subcooling taking place in the sub because we're already doing so much of that in the main. So right now we can eliminate another liquid gas separator in the sub BCs, and then if we're doing subcooling in the main, this is where we're going to get unique with 3 pipes. So that main BC has got that gas liquid separator. So we take the gas off the top. That is now going to be heated gas to get to another sub BC.
Yep.
We've got subcooling that we'd managed in there. So we're going to take that subcooling. It's going to have a liquid pipe. So I got a high pressure hot gas and I got a high pressure liquid. So I've got 2 things running out to that sub. And then I've got to have a path for that return gas, that suction
To
gas.
come back.
So now I got 3 pipes between our mains and our subs. If we got up to 11 subs, we're teeing off of those 3 lines to each of our subs.
But each sub does have a subcooler. We use the
one
primary, the main BC. We use one of the subcoolers for the primary, and then we run it through a second subcooler in each of the subs. Correct?
Yes,
Yeah.
sir.
No gas liquid separating in any of the
Correct.
subs.
In any of the subs.
So that's why we need that 3rd pipe,
Yep.
right? That hot gas pipe. This is great. This is an unbelievable explanation of how I think, without seeing the system, without seeing diagrams, Dwayne, you've done an amazing job
Dwayne,
of explaining.
unbelievable, Dwayne. Thank you so much.
Thank you, guys. As you can tell, it's a passion.
Yeah,
right?
no, it is. You can absolutely tell
Some
that.
guys are reefer nerds. I guess I'm a reefer nerd.
No, I think we all
no,
are.
I wish I knew half of what you know. You just, and you explain it so well. So thanks. It's really,
and for Paul, that would be a big deal.
yes, it is. Somehow you take something very technical and you simplify it for
Yes.
us. And that's really good. For me, I need
That's what I
need
do for
simple.
myself.
Now I'm ready for some baklava.
Oh boy, here we go. We started
we
with
gotta go
cars, we went to
dessert.
food, and we
I
ended with
kind of
food.
like the Mustang, though.
Do you?
Yeah, the cherry red
well,
Mustang.
We could have
you know?
baklava in the Mustang.
You know what else I would do if I had my Mustang? Right? I ran across this new chain of restaurants just on Boston. It's called Kava. Right? It's called Kava. No, it's a chain. I guess it's national and it's growing. It's like a Chipotle, but it's Greek food. So instead of going in and picking a tortilla and all your stuffings
Is
and
that
everything else,
Chipotle?
yeah, the Chipotle.
Is that like tortilla?
Yeah.
I think I need an app for my
No,
phone
but
on Greek
it's-
foods
you
here.
go and you pick out the pita bread and you pick out your stuff and you come up
The
with a
pita
hero
bread?
at the end.
It's
I'm
not
telling you,
anything
it's
like
called
pita?
Kava. I think you guys should look it up. Pita.
All right, well, that's
Pita.
good.
Pita,
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 Kava.
Paul,
Not Peter.
and not Pita,
Pita.
not Pita.
Yeah. I got some training today.
So,
Do you?
yeah, so if I had a Mustang, that's right.
Okay.
All right, thank you, everybody. We'll see you on the next one.
Thanks, guys.
Adios. Hasta la vista, baby.